Hello, Year 9 Chemists. So, welcome to today's lesson. Today's lesson is about making insoluble salts by precipitation. Now, not all salts behave in the way that you and I know salts to exist. So here I have some common salt, and this is some sodium chloride. I've got some sodium chloride here, and I'm just adding it to some water. This glass I actually got from a juice company. 48th year Spirit of the Union National Day. National Day seems to be a long time ago now. So I've got some dark tissue paper that I was kindly donated by Mr. Pohotsky. And what I'm going to do is I'm going to stir these crystals in this water. And do a little experiment. So you can actually see that the salt has pretty much disappeared. Well, we say disappeared. If we were talking to a small child, we would say disappeared, but a slightly larger child would understand the concept of dissolve. And now, as GCSE chemists, we understand it to be a little more than that. We understand it to be made up of ions that have broken up. These ions have certain charges, and those charges have positive charges and negative charges. Some of them may be multiple ones, but the vast majority of this, in fact, I can't see any crystals left over. The salt has dissolved, completely dissolved. So we're used to that type of phenomena, and pretty much the salts that we have been looking at have been salts that are soluble. And it might be interesting to note that there are some white little bits of powder in here. And you might think, sir, your experiment's not working. You can see one or two in there. Those are actually anti-caking agents. If you look at the salt pack, you can see that it contains salt. How helpful for them to actually put NaCl as the formula as well. But you can see that there's some anti-caking agents, and those anti-caking agents are just actually added to make sure that the salt that you have, your common salt, doesn't stick together. And so when you have your application of salt, you can actually have the salt free flowing. Add a bit more. So the salts we have looked at pretty much so far have all been soluble salts. You can obtain them as crystals. And you can evaporate solutions and obtain them that way, but not all salts are soluble. And we're not necessarily talking about adding lots and lots of a soluble salt until you get to a point where it's a saturated solution. So there are some rules about salts, whether they are soluble or not. And what I'd like you to do is I'd like you to open up your books to page 117, to section 1.7. And there are some rules. Okay? So this table over here talks to you about how certain salts of sodium, potassium and ammonium salts, all salts of those, are soluble. All nitrate salts seem to be soluble, all chlorides, all sulfates. Sodium, potassium and ammonium carbonates are soluble as well. Now there are some exceptions. So the chlorides of silver and lead are not soluble. The sulfates of calcium, barium and lead are not soluble either. And apart from sodium, potassium and ammonium, all other carbonates are insoluble. Now this is a topic that's in supplementary, because as a chemist we need to be able to recall the solubility of these particular salts as well. So I'm going to be testing you on that in the quiz. Now, how do we make insoluble salts? We can actually utilize this to make an insoluble salt. The example that you have in the book talks about making barium sulfate. The video that I'm going to be asking you to watch is quite a lengthy video, but it takes you from start to finish of a practical that's pretty much done in someone's garage. I like the video because it has high quality definition and it answers questions along the way, but the only thing that I wish that the video had was a bit more control over the suffixes, things like the 2s and the 3s below the lines when they should be. Let's have a look at this. I'll take you through it. A solution of barium chloride contains barium ions and chloride ions. You can see them. The barium ions have a 2+ charge. Why do they have a 2+ charge? Well, the answer, of course, is because they're in group 2. So they are a metal, they lose their 2 outer electrons, they form a 2+ ion. Chloride, 7 electrons on the outside, needs 1 more to fit the electronic configuration of the nearest noble gas, so it's a Cl-. And the water molecules are represented by these blue circles. Similarly, here is a solution of magnesium sulfate. Now, according to the table, magnesium sulfate should be soluble, and barium chloride should be soluble as well, because it's not silver or lead chloride. Magnesium sulfate should be soluble. However, if we mix the 2 solutions together, we're going to get barium ions meeting sulfate ions. Now, they are very attracted to each other, even more so than the magnesium is attracted to the sulfates. And when you mix the 2 solutions, the barium and sulfate ions, they bond together. Barium sulfate actually forms as a precipitate. There's nothing that the water molecules can do about that to balance and counterbalance that. So the equation for the reaction is barium chloride, Ba 2+, Cl has a minus, so you need 2 Cls. See how we've got the state symbols, aqueous, aqueous, solid, S for solid. The solid now is coming about because you have a precipitate. The magnesium ions and the chloride ions, however, seem to be spectator ions, and we covered spectator ions last lesson. So they stay in the aqueous phase. The Ionic equation, once we take out all these spectator ions, is Ba2+, aqueous, plus SO4 2- aqueous, reacts to form BaSO4, which is a solid. So the steps that you take in making this barium sulfate are steps that you're actually going to be seeing in the video that I found for you. But the video I found for you is not of barium sulfate. The video I found for you is of another salt. It is magnesium carbonate. So I'll let you watch the video and you'll be able to see these 5 steps, and I'll be asking you questions about the steps too. Choosing the starting compounds. Chemists can actually use this technique to make a compound, a desired compound, so long as they remember what these rules are. So if I wanted to make magnesium carbonate, I would have to get 2 soluble salts, one of them being a magnesium salt, which is soluble, and one of them which is a carbonate salt, which is soluble. If I mix them together, so long as the product has spectator ions which are still soluble, I should then be able to use filtration in order to separate out my insoluble salt. So to precipitate an insoluble salt, what we need to do is we need to mix a solution that contains its positive ions with one that contains its negative ions. That's got some fantastic applications. We use insoluble salt precipitation to make coloured pigments for paint. Sometimes used to remove harmful substances dissolved in water when we clean up wastewaters, because if the harmful substance can be precipitated out, we can filter it. Good old-fashioned photography used precipitates of tiny crystals of insoluble silver bromide. The mixture is then coated onto clear film, giving photographic film. I do miss the days when we actually used this. We were only limited to around 24 or 36 photos per film. I remember saving up and spending a couple of £100 on cameras like this. I still have some films that I hope from a couple of decades ago that I hope still retain their pictures. Photos from my university that I did not develop just yet back in the UK. So the photography of this type of film is still a very classic way of using film technology, particularly if you are a director of a movie and you just want that old sepia effect. So the solutions are silver nitrate and potassium bromide. They are soluble. Mix them up on the clear film and precipitate of tiny crystals of insoluble silver bromide form. So the actual soluble salts that you use, they are crystals, but you dissolve them in gelatin. The precipitate that forms out of it is silver bromide, and then you coat that onto clear film and you make the photographic film with that. And silver ions are a curiously behaving ion. When light strikes silver in the presence of bromide ions, the silver bromide can actually break down and it forms a solid, a silver atom, or a couple of silver atoms, and bromine liquid as well. The bromine just evaporates off. Today we've got digital cameras that are more popular, but the light strikes a surface that generates a current, and this converts to an image by a little computer inside the camera. So the questions that we can ask ourselves are this. Now, what I really want you to do is I really want you to tackle the questions without the need to look at the suggested answers that are at the back of the book. And they are suggested answers as well. What I do not want to have when I do my checkpoint quiz with you is I do not want to have copies of the answers at the back of the book. What I need to have from you is I need to have the answer in your own words without having looked at the answers. I have to insist if the answers are looking as if they have just been plainly copied from the back of the book, it turns it into a meaningless exercise and I will have to not be accepting these answers. I cannot accept copies of the answers at the back. If you want to check the answers at the back, by all means do. But do not copy the answers at the back. I want to know what's in your head and I'm interested in your learning journey. But let me give you a little bit of a helping hand as to where to get these answers from. Question number 1 talks about what precipitation means. And you have to explain it in your own words. So precipitation is all to do with this process involving insoluble salts. Try and put a little bit of information about how it forms a solid insoluble salt. Question number 2 talks about name 4 salts that you could not make by precipitation. So what you would have to do is you'd have to look at this table here and come up with 4 salts. Now if it says calcium, barium and lead sulfate, don't just put calcium as a salt. It's calcium sulfate. Barium is barium sulfate. You can think of a carbonate. For example, calcium carbonate. Calcium's not here. You can use potassium, but potassium is soluble. Ammonium is soluble. But you have some suggestions here as to what you could have as the cation, as the positive ion. So barium carbonate could be a choice. So you should be able to come up with 4 of your own salts that could be made by precipitation. But the question is asking you to name 4 salts you could not make by precipitation. So if you actually had that question to answer, you could say sodium chloride. You could say sodium sulfate. That's true. Okay. So sodium sulfate would work. Potassium sulfate, that would work. All nitrates. So you could have silver nitrate, lead nitrate. If it says all, that would be suitable. So let's come back to the question again. It says name 4 salts you could not make by precipitation. Salts that you could not make by precipitation are salts that are soluble salts. Come up with your own. Question number 3. Choose 2 starting compounds you could use to make these insoluble salts. Again, what you'd have to do is you'd have to look at the 2 parts. So calcium sulfate, we could not use barium sulfate because that is insoluble. Lead sulfate, you can't. But for calcium sulfate, you could use calcium chloride. And the other part was the sulfate, so you'd need a soluble sulfate that's other than these 3. So sodium sulfate could be useful. Potassium sulfate is another example. Ammonium sulfate is also soluble because it's not here. Lead sulfate, however, would not be suitable. So choose 2 starting compounds you could use to make these insoluble salts. Question number 4. Write a balanced equation for each reaction you chose in 3. So in order to do that, you would really need to go back to the section that was full of ions. Remember, when you're talking about ions, you really need to make sure that you have a full working knowledge of what the charges on each of the ions are. Now that information is in section 4. I'm just going to whiz back to section 4. These are the ions. This is 4.4. Ions are the first 20 elements. You need to really piece together some of the information there in order to do that question. Okay? You've got compound ions here as well. So commit these, as many as you can, to memory. Balanced equation for each reaction you chose in 3. Seems to be a very challenging one for you to do. So I'm going to ask you to just give me 1. What is a spectator ion, and identify the spectator ions in your reaction for number 3. I'll ask you to just do 1. Write the ionic equations for your reactions for 3. I'll ask you to choose just one. Why is precipitation necessary in making photographic film? The answer for that question is here. Thank you very much for watching this guidance video. I'm going to give you lots of time to watch the other video, and then what you'll be able to do is you'll be able to answer the quiz questions and summarise your information there. This lesson should not take longer than 15 minutes to produce. Thank you, stay safe and stay at home.